And I found one more stamp with a date code C, 1976, for this main board. And then this top of the high voltage is 1975. So this is the power supply, but it's not only the power supply, it's also doing a lot more than just a power supply. So let me try and recap a little bit. I've been spending a lot more time on this. So the little transistors down here in this section right there, and the capacitors you see here, that's a little 21 kilohertz oscillator. And this oscillator also handles this switch mode converter. So my 46 volts comes in here. I put in a little local decoupling capacitor here because normally there is only one that is down here on the main board, but I want to be able to play with this board alone, so I just had to put in one there. So this oscillator also, there is a feedback winding, and this feedback winding goes to this base, but there's also a little shutdown transistor here that takes this base signal and short it down here. And this signal is connected to this capacitor, and we got some other transistors right here. It's a PNP transistor, so no, this is the oscillator. But anyway, this PNP transistor is a shut-off transistor, and it measures the output voltage, the plus 15, and this plus 15 is regulated again using this emitter follower, and this is the 15 volts output rail. So the idea is when the 15 volts is too high or too low, it will turn on and off this PNP transistor, and this will kill this oscillator signal, and then it will kill this transistor, and then it will shut down this one, and then the voltage will drop. So this is how you have this little regulation. And some of this is of course not working, and the reason why it's not working is because when it is not working, the voltage goes absolutely crazy high, plus minus 33 volts instead of plus minus 15. And none of those chips or regulators, or the opamps for that matter, can handle that much voltage. So this is why everything here is more or less killed. When it is killed, it is in a state where it's just continued to blast maximum output voltage. So I think this is a really stupid way they have done it, and I need to remove all this. But I want to probably just disable this entire switch mode converter and just plug in my own plus minus 15. And this 5 volt system here is just for this regulators and stuff like that, is what I think so far. It may be also a reference to some of this stuff that's going on here. But anyway, I need all those op-amps, and this system here is also a part of voltage current protection, enabling, and doing all sorts of stuff as well. And I think the oscillator here, the output from this oscillator goes via some diodes. You see, diodes and resistors right there, and those goes here on those 2 pins, and I think that will be our main oscillator input to the other board. So I need this to be running, and but this happens if I just power this area here at 5 volts. So I don't really need all this stuff. I mean, I can just put 5 volt in here, then I have the oscillator, put in plus minus 15, and then I have all the op-amps running. And I think this is my next step to see if I will be able to get just a few millimeters ahead with this one. Just came home from a little flea market trip all the way to Jylland. Look at that. This is one of the little goodie bags I found, full of power supply components and spare parts and all sorts of oldies. And I just went through this, and look at that. 4, 7, 2, 3 regulators in sockets. And this is exactly what I need. I need 2 of them, I think, for my little project. What kind of luck is that? Because I think that is one of the main problems with this regulator right here. Those two, they go red, glowing, burning hot. And the different references and all that is working. And of course, if it's not working, then the voltage just goes to 33 volts and then self-smash them. So that is, of course, a big problem. And there isn't any current protection and anything like that. So when something is not working, it's definitely going to murder all the opamps in the entire unit. I don't think the 741, will that work with plus 33 volts, negative 10, 12, something like that? So that is nearly 50 volts. I mean, that is a little bit too much. So I need to replace all of those as well. And the other board got quite a lot of them. Oh man, that is annoying. So now I got the two new, I don't know exactly. They're from 1974, so I don't think they're new, but I got them nicely into the circuit board. But the whole regulator system here is definitely still not working, and it's driving me completely nuts, because that will be the 5.1 volt Zener diode, and here's another local Zener diode for this one, and all the Zeners and all that kind of stuff around here is working, and all the resistors, they seem to be correctly mounted and connected, and everything like that is working. All the transistors that's involved, they have been desoldered and added a little green dot just so I can see that they have been changed, and they are of course working. So I got one more little idea that I would like to experiment with. But anyway, so the oscillator here is feeding out 21.6 kilohertz. And that will be the frequency that goes into my other main board. This is the board that drives the output stage. And let's show how that one actually works. So I've added a little label here so I can easier figure out what is going on. So if somebody else got this one day and they want to try and repair it, here is the information that I've got so far. So this will be the oscillator input via a resistor and a capacitor. So it goes to this transistor right there, and then it goes to another transistor and another one. This is the positive 26 volts. And look at that. So this NPN transistor actually activates this PNP transistor, and this PNP transistor is the one that drives the NPN driver and the 4 NPN transistors for the 4 transformers. So a lot of transistors in the signal chain, and this signal here for this transistor also goes, see, to some opamps. So the idea is all the opamps, there of course measures the output voltage, the output currents, the how many watts and the whatnot, right? And then it pulse skip by disabling the pulses for that many milliseconds for the voltage to drop down to whatever it is. So this is a pulse skipped regulator and not a real pulse with modulator or anything like that. And then it just kills the pulses, and then everything is back into regulation. I'm not super happy about the way that this works. So if you remove all those op-amps, you get full unregulated mega maximum output, and you can imagine what that will be. Quite a lot of 1000 volts, because in my earlier experiment I put in 150 millivolts into each transformer, and that gave us 10 volts per transformer system, and we got 4 of them, so that's 40 volts. So now what happens with 46 volts of drive, and okay, square wave is half the, I don't know, but it's probably like 4 or 5,000 volts or something like that. It's way too much. So it needs to be in regulation, and it needs to have all those opamps that's working. But all of these, they are of course blown to pieces by this mega overvoltage from this power supply. Or if they still work, I mean, how reliable are they? How much can I trust everything here? I don't know. But now I want to try and feed in plus minus 15 volts to this system from another power supply, because this is, you can easily do that because we have the diodes from the different windings in this one, and I can just feed in the voltages, the correct voltages after the diodes, and then everything will be fine. And I need the 5 volt to get this oscillator running, so I just need 3 power supplies to get this up and running, and then the 4th one can be my 46 volts for this drive, and then I can just crank this up real slow. But first I want to see that I get this pulses all the way to my output stage, and this way I will have output. And if I don't have this, then it's of course some of the opamps. This is the high voltage output from the top high voltage rectifier board, and the high voltage go via all those resistors I marked with red here to the 2 red output systems. It is of course the same voltage, and you can see the 2 black wires from the 2 black, or the 2 negative outputs, and they go together into one common ground. So the idea is you can measure 2 different currents. You're probably doing 2 parallel experiments at the same time. So you've got A and B experiment, and this way you can check the current, what is going on B and what is going on A. The fun thing is this power supply can only give you 20 milliamps maximum current, and at least this is what I think it is, because we got a power times 1 times 10 and times 10. I don't understand exactly what that is doing. And then you also have a current down here. Look at that. The current is times 10. So maybe it can do 10 times 20 is 200 milliamps. So 200 milliamps at 2000 volts, that is 400 watts. So now it makes good sense. Why is this transformer this size? So this is probably like 400 or 500 VA this size. And also the rectifiers and everything. Now it makes a lot of sense. So those 200 milliamps, and this is of course why you have this meter reading in times 1. You have 20 milliamps full range, and then you have this A and B. So let's just go to B, and there you have the output voltage. I just put in 10 volts on this point using my little power supply right here, and then I'm measuring the output is 10 volts. So the idea is I take my output to a known load resistor, and then of course I measure what is the voltage over the load resistor. This is my output current, and then I simply adjust the input voltage a little bit up, because we got voltage drop until I have exactly what I want, and then I can read out the current. And then we got those 4 trimmers right here for the 4 current ranges, and I have of course adjusted those so they are now super duper spot on. So it's really good to know for sure the amp meter is working. voltmeter, I need to do a little bit more experiment. I try to input some voltage and then see that it is actually moving. But to know it's moving correctly, I need to input some more voltage. Otherwise, I'm just getting a few millimeters down here, and this is not enough. I mean, I wanted to give it like 1,000 volts, but I don't want to backfeed it 1,000 volts. But there isn't really any reason why I shouldn't be able to do that, because everything is diode rectified individually and then series connected. So I mean, there's nothing there in the way of doing that really for my experiment here. But all we have here is for the current measurements, A and B, and down here we have all those resistors doing the voltage measurements. And it is a little bit weird exactly what is going on, but I think it is measuring the voltage differential, something like that. And it's probably also doing that with current, because the current, we got the current limiter, right? And all this, and the voltage needs to go somehow from all those measurement resistors to the op-amp regulation boards. And we also need to have and understand how is the voltage set point, power set point, yeah, and of course this current set point and all those things, they're connected to this connector down here. And then all those signals come up where? And then I will be able to poke around on my op-amps and get this thing up and running. But it's already way too many million hours into this but I'm not giving up this. I'm not giving up yet. About the current measurements or alignment. So here is 82 ohms, and I have of course measured and verified this one to be exactly 82 ohms. So my idea is I put in the current here and then I measure what is the voltage over this one. So if this one is about 8.2 volts, I should have 100 milliamps. Wouldn't you say that? And it is a little bit itsy bitsy piece over. And then I just take my little trimmer and adjust it to be as accurate as I want. And this I of course do with all the 4 trimmers, and that is as easy as that. I think I got a little bit of a breakthrough here. As you can see, this signal here is the output to one of the transformers. I didn't yet change this transistor because it's not relevant for all the debugging. I can just use the 3 that is already working. And it actually doesn't matter if I get high voltage from 3 of the transformers. I will just get a little bit more PWM and then still get the feedback and everything. But so far, we got 21.7 kilohertz out in maximum duty cycle. So this is full power. And I got all the voltages up and running. At the moment, we can see the high voltage LED here is turned on, and that is simply because my input or my output voltage here, I'm using another power supply to feed in here. And this is just 10 volts. If I give it 9 volt, it turns off. So from 10 volts of output, it already have this high voltage warning. So that just means we have more than 10 volts, okay? So I have a load resistor here, and we can now see some current. And I really wanted to see those LEDs doing something. So this is the current potentiometer. And see, there's no response, and of course there's no response there as well. But I was expecting those LEDs to do something when I have current going. Why isn't it, doing anything at all? Also, this power thing, there's also no response here, no matter what I do with that one. It is in the voltage mode no matter what. And here's another funny thing. when I have 10 volts on the output, and if I turn the set point under 10 volts to all the way to down, again, you need to see the PWM going down, or something at least to happening there. So I want to put back my disabled transistor I've removed, and yeah, it is running burning hot. It's using 12 watts, this auxiliary power supply right here, and I've added some heat sinks to those regulator chips I changed because they just run this crazy warm. And to be able to see if the plus minus 15 is running or not, I just put on some LEDs right there, and as long as they are nice and shiny like that, I know those two voltages are good. So that will be the 15 volts for all my many op amps. So this is just this board. I'm taking out all the op amps and putting in some sockets and stuff, and then I will do the same with the other 3 op amps on the other board. But I mean, I don't have a schematic, and what if it's just one of those transistors that's causing some disable or some stuff? I mean, without a schematic, I need to hand draw everything, and I just try and figure out what takes shortest amount of effort and to get this up and running. So, and it was just it's not taking that long time just to poke out all the op amps. I mean, they got more than 15 volts and they handle 36, so that is a good place to start, isn't it? It's driving me super nuts about this. So with all the new op amps and everything, all my circuits seems to be working, but I still have no PWM control. So I started to map out this connector that is connected to the different potentiometers for a set point and all that. And this is the voltage set point potentiometer, and it is completely disconnected. So it's blown up inside. And of course, this is why nothing works. So now I will write down exactly where it is connected, what wires go where and all that. And then I will make a little documentation like this. So this is the start. I started with the current potentiometer, and this is marked in like this. And this works, of course, perfectly fine. I want to show you something that happened. Check out the scope, and now I play around with the voltage set point. So if I want some more voltage, oh, look at that. And if I want some less, I can have it. See, it's changing the pulse width for the power drive. So, and if I crank this up a little bit like that, and then I simulate that we have a voltage output using another power supply, and then I crank up a few volts of, wait, see? So now it measures, and then I go down again, like that. So it measures the output voltage and compensate for that. And then I can crank up the set point a little bit more. That's weird. Okay, so I'm cranking up the set point, and then it's getting full. And of course, I didn't change the feedback voltage from the power supply. So that means it's just going to stay there at full. So, see, let's go down again. See, nothing here. And it is, of course, so this point here is about 10. See, right there. This is about 10 volts, which is also the point of this LED. And now the feedback is higher than the set point, right? So we don't have any PWM. So if I turn off the output, see, now it sees nothing, and then it cranks up the PWM. So I'm quite happy about this. It should also be able to go to 0 PWM at 0 volts. So now I have 0 volts output. And what happens if I crank this all the way down? See? At that magic 0.0 point, it also goes to 0. So that is very, very good. There is, however, another little problem. See, if I crank up the PWM, this LED turns off. See? So what exactly is happening with this one, I don't know. Maybe some of those other LEDs are not working. Maybe that is the problem. And see? Now it's giving you full PWM. And then I should be able to load the output, turn on some voltage here. It's going to go through the resistors, and this is going to create a voltage drop, and it's going to measure, oh, we got some current, and then I should be able to take this current limit point up and down, and then it should also affect the PWM, and it should also affect this LED. None of that seems to be working, but I think it has something to do with this sense system. This sense system is actually floating. There isn't really a connection between the sense system and the opamps. For some really special reason, there is an extra winding on the switch mode power supply, and this one supplies some of the voltage sense systems, and then it's somehow connected to the voltage feedback and all that stuff. And I also haven't yet understood how it can be in sync with the PWM or with the oscillator, because the oscillator is just a full 50%, and then it's somehow able to do this by locking to the incoming oscillator signal with the opamps and all that. Again, remember, I do not have any schematics. So far I figured all this out by just trying and fool around with these things and changing all the defect opamps and all that kind of stuff. So I think I will now try and close the loop and get some high voltage out, try and load it a little bit, and see if I can get the current sensor or current regulator up and running. But this is a good day where I finally got some results.